All right, so we're going to be talking about standard deviation, a very, very important concept. We will use it all year long. It's fundamental, basic, fundamental idea that you have to understand in statistics. Now, the basics about standard deviation is that it is the average distance from the mean. So if we're thinking about our class data of all of our heights, then we would want to know how far, on average, these heights are away from this mean of 68 inches. See, so like how far are these numbers away from the mean on average? Okay, so that's what we're looking at. And so we're going to compute that. Now, we typically will do the computing with the calculator. There's a function in the calculator that'll compute it for us. So after today and tomorrow, we'll be doing that with the calculator. However, there are some reasons that you have to know this. We have to go through this by hand first. And here are the reasons that we have to go through this by hand. It's a scary looking formula. You're like, what the heck is all that stuff? It's a scary looking formula that I'm going to walk through with you today. Because in order to understand what the idea of standard deviation, you have to know what these things are in the formula. Also, I have had multiple people that have gone on and taken some statistics classes in college, whether they took my test and got credit for it or whatever, for whatever reason they ended up needing to take statistics in college. And many times I've gotten from probably at least 4 or 5 students that had their professor made them get standard deviation by hand, not just in the calculator. So that's another reason that I want to show this to you and introduce this to you by hand. All right, so let's first take a look at this formula we got here. So if I want to talk about, remember, I want to talk about the average distance that our heights are away from our class average of 68 inches. So how would I get that average distance? What do you think would be natural for me to do? Find out what that distance is and find out what, that's 1 away and this is 2 away and so on. Find out, add up all those distances and then what? Average it. So add up all those distances and divide by how many there are. Okay, so that would make sense to me. But look what happens. For example, what distance are all these people that are on 68? All these people that are on 68, what is their distance away from the mean? Okay, so all of these people are 0 away from the mean. These people are how far away from the mean? Okay, they're 1 in the negative direction. We do need to account for the direction. So they're 1 away. These people are 2 away. Then these ones are 4 away and 5 below, 7 below, and that one is 9 below. Okay, so if I took all of those, in fact, I'm going to do this real quick. So if I took these numbers, -1 happens twice, -2 happens once, -4 happens 3 times, -5 happens 4 times, then -7 and -9. If I added those up, and then talk to me about what's on the right-hand side. All of these distances over here are what? Positive ones. Okay, so I've got 3 of them that are +1. I've got, these are +2, +3, +4, +5, and +6. Okay, so let me go ahead and get those guys going. I got 1, 1, 1, 2, 2, 3, 3, 4, 4, and then I got 5, 5, 5, 5, 5, and 6. Well, guess what? If I took this sum, in fact, did anybody sum up one of those columns? This one's -52, and guess what this other one over here is? +52. So if I wanted to add all of these up, and I added, of course, my -52 plus my +52, what does that get me? 0. And that would essentially say 0 divided by 32 is 0. So that would say the average distance from the mean is 0. And tell me, by looking at this picture, is the average distance from the mean 0? No. What would this picture look like if the average distance from the mean was 0? Very good. If the average distance from the mean was 0, every single piece of data would be 68. Okay, would be the mean. And so, obviously, that's not the case. All right. So we got that going on that we have to deal with. Okay, so let me show you how the formula deals with that. Why will that not erase? I do not know. Okay. So here is what the formula does to deal with that. I think it would make sense to do absolute value. Just get all those absolute values and add them up, but they don't do that. Take a look here at the formula. So here I am teaching you what all this stuff means on this funky looking formula. First of all, this x with a little I, think of that as every single one of your individual heights. And then subtract this x bar is the mean. So what, if I do your height minus the mean, what is this giving me? Your height minus the mean. Your distance away from the mean. Okay, good. So all those little -1s and -2s and +3s and +5s, that's what all those little distances, these are called the deviations. Okay? So that is your deviation from the mean. How does this formula fix it so that it's not negative? What's it doing to fix it so it's not negative? It is squaring it. Good. This is the mathematician's solution to not having the negatives. They are squaring it. So that means that's what we have to do with all of those pieces of data over here that we had. We got to square all these guys. So we're going to square them. I wish that all of them would show up. Some of them aren't. Those ones over on the left are not showing up. That's not good. So, poo. So I tell you what, I want, geez, erase. Oh, you have it written down? Okay. Well, I mean, I can refigure it out. It's just kind of annoying. There was 2 that were -1, a -2. 3 of them were -3. 4 of them were -4. And then there was a -6 and a -8. Is that right? Okay, so what did I say we have to do to fix it? Square them. So square these numbers. 1 squared is 1, and 1, and 4, and 9. 9. You know what we're going to end up doing with all of these squared numbers? What do you do to get an average? Add them all up. So I want somebody to work on adding up all of these squared numbers. And then I'm going to come over here and square these. 1, 1, 1. What?
Instead of -8, it was -9.
Oh, it was -9. Okay.
And -7.
Oh, really? Dang. Are you serious?
And there was no
-3 should be -4.
Okay. Okay. Okay, here we go. So what we have just done, and I don't want to get this too big, we have taken these deviations and we have squared them. And so that's what I have in this list. We've taken these deviations, we squared them. Now, look at what the formula tells you to do. It has this big sigma right here. What does this big sigma mean? To do what with it? Sum. This symbol here is summation. So isn't that what you would do in averaging, is you are going to sum up all those numbers? So this is summing up all of those deviations squared. So let's go over here to our data. So that means I'm summing up the negative deviations and the positive deviations for a total of 506. Okay, so there's our sum. Now if we're getting an average, what are we going to do then with that sum? Divide by what? How many we had? And we had how many in our sample? We had 32. However, look at this formula. It doesn't have you divide by n. It has you divide by n minus 1. Now, there's kind of a little tricky statistical reason there, and I'm not going to go into much of it, but basically think of it as this is a sample and not the whole population, and there's some, I don't know exactly, I've tried to look it up different ways that it could be explained, and it's not real easy to explain why. But when it's a sample, we want to be on the safe side of on our standard deviation, and so we divide by n minus 1. So we're not going to divide by 32, we're going to divide by 31. So let's take this number, divide it by 31, and what do we get? 16 point, what? 3. Okay, 16.3. Now, this number is called the variance, and so this is a vocabulary thing that I need you to get. So, in fact, we're going to write it at the bottom of your page 7. Oh, there's that data that was missing. So, here's the bottom of your page 7 where it talks about sometimes you are given the variance instead of the standard deviation. So you need to know that there is a difference between this thing called variance and standard deviation. Variance is what you get before you unsquare it. So it is the standard deviation squared. Okay? So the variance is that standard deviation squared. Here's another way of writing it. If I take the square root of the variance, then I get standard deviation. Okay? Some people, it makes more sense if it's in number form. So here's an example. If I tell you that the variance is 9, but you need to do calculations with the standard deviation, then what is the standard deviation? 3. Good. Standard deviation is the square root of that variance. Okay? All right, so that's one thing that you do want to be careful for. And I can tell you this, there is a problem on a test. I don't know if it's this test that we do now or if it's the next chapter 6 test. But there's a problem that's a multiple choice problem, and it's very simple if people would recognize that it gives you the variance and not the standard deviation. And all you had to do was take the square root of the variance and you had the standard deviation to do the work with. But people lose that. So I'm trying to tell you, just watch and see if they give you the variance so you know if you had to square root it or not. So when we come over here and we say that our variance is 16.3, then how do I get the standard deviation of that? I'm going to take the square root of 16.3. And so what is that value? 4 point what? 4.03. Okay. So y'all's standard deviation, it's a sample standard deviation, is 4.03. Now, as a frame of reference, let me kind of tell you how some of my other classes did. First period, their data was really nice and closely compact. Their standard deviation was 3.3. Second period had quite a bit of variation. They had two people that were 59 inches, and they had a person that was 76 inches. So they had a very wide span of data, and their standard deviation was 4.7. So when their data was more varied, they had a bigger standard deviation, okay? Third period had a standard deviation of 3.1. So tell me about that. They were very close together. They did not have anybody way far out there. They were all nice and compact, closely clustered around the center. And y'all are somewhere in between. Y'all are at what, 4.03? Okay. So y'all aren't as closely clustered together as third, but you also don't have as wide of a spread as second. Okay? All right, very good. So that's essentially what the standard deviation is. And so in summary, we need to know, see, here's this, getting the last thing is unsquaring it, doing that square root. So in summary, let's review this formula. You need to find this deviation, the distances each person is away from the mean. And then, why do we square it? So that it's not negative. And then we do what? What does this sigma tell us to do? Add up all of those, and instead of dividing by n, we divide by n minus 1 because it's a sample of data. And finally, well, what does that give us? Before we square root it, what's that called? The variance. And then we unsquare it, and we get back down to the standard deviation. Okay, one little last tidbit we've already kind of said this, but do you remember that the sum of all of those deviations, do you remember the sum of all those negative values and the sum of the positive values, the negatives plus the positives, summed up to 0, and that's always. The sum of the deviations is 0. That's a rule. That's a common multiple choice question on the AP exam. So there's a couple of tidbits to keep in mind. All right. Now let's take a look at this next page here. And we won't actually have to go through all of this 7.1 through 7.3 because that kind of does what we just did. But this first set of data is really interesting. Look, here we have 2 data sets. Data set number 1 has an average of 32.3. Data set number 2 has an average of 32.8. So their averages are about the same. But what is very different between these two? Their standard deviation. So I need somebody to explain to me, why is this standard deviation 2 and the other one is so huge at 18.9? What is making that difference? Carson.
In like set 1, they're all really close together, the numbers, and in set 2, they're over a larger range.
Perfect. Do you see this? Set 1. Do you see how closely clustered these numbers are to the center? The mean. And in data set 2, do you look at these? These are going from 10 to 58, and the other ones are even spread out. So they are much more varied. So this data set 2 is much more varied, more spread out, and that is why the standard deviation is so big. Data set 1 is closely clustered around the mean. So the more closely clustered you are around the mean, the smaller the standard deviation you have, because that's the average distance from that mean. Okay. So that's pretty much it as far as what the idea of standard deviation is. So what we got going on here in the rest of this page, this is just taking you through the formula as if we did not have the height data that we did, but we did it with heights because I thought that was kind of more pertinent to you. So this is going to just take us through that with a different example. Now, I like this one. This one is a real-world example in the 2000 season. This is top 10 rushing leaders. I don't know if this is in the NFL or what. Is it? So we've got these people here. This is in 2000, quite a long time ago. So these are, is this NFL numbers? Do you recognize who these people are? Okay. All right. So let's take a look. We have the average and the standard deviation. And so I want to talk to you about Stephen Davis and Corey Dillon. If we look at both of them, Stephen Davis's average is 87.9 and Corey Dillon's is 89.7. So their averages are about what? The same. But Stephen Davis has a standard deviation of 34.1 as compared to Corey Dillon's at 73.2. Do you see how look at Stephen Davis's data. Do you see how it's squished up really high? Because it's more compact. It's the same amount of data squished into a smaller area, so that's why it's a tall curve. And you see Corey Dillon's, it's the same amount of data, but it's more spread out. So that's why it is wider and flatter. So this one is wider and flatter, and it has a larger standard deviation. Okay? And this one is more compact. And so it has to be all squished in there. So that's why it is taller. More data is squished in there, more closely clustered together. So of these two people, which player do you think is the preferred player and why? Oh, wait, what? Corey Dillon is more preferred? Davis is more preferred because he is what? Yeah, he is more consistent. You can count on him. He is more consistent. I think that you said more consistent. You just said the wrong person, right? Okay. So he's more consistent. Corey Dillon is unpredictable because he is so varied. Okay, so you may get some games where he does really poorly and some games where he does really well. Even though it averages out the same, you want to have the more consistency. Okay, so let's now talk about part of your assignment is to do pages 8 and 9. So the first part of your homework is to do pages 8 and 9, and I want to talk you through it, and we're going to do part of it together. So number 1 says find the mean and the median, and I think you can do that. That's no problem. Number 2 also says find the mean and the median. Now, but look at this second part. This part right here I want to discuss. This says, suppose this first observation had been 204 instead of 244. Talk to me about this number 244 compared to the rest of the data. Does 244 seem like it or outlier? I think it's an outlier. The next biggest piece to that is 211. So, oh yeah, 244 is an outlier. So they're gonna, what if they took 244 and they changed it to 204, then it wouldn't be an outlier anymore, right? Okay. This question is asking then what's the new mean and the median after you make that change, and it asks you about this idea about being non-resistant to outliers. So let's talk about resistance to outliers. Okay, so let's write that down. If you are resistant to an outlier, what do you think that means? You are not affected by it. So if you are resistant to an outlier, then you are not affected by outliers. So that's a concept that we will address in this chapter, and this just kind of gets you started. We're interested in knowing what things are affected and not affected by outliers. So being resistant means not affected. Okay, and then the next part asks you to find the trimmed mean, but let's look at number 3 real quick. Number 3 asks you to take this data and create a split stem plot. This is not a double stem and leaf. A double stem and leaf was where you had 2 sets of data and you went to the left and you went to the right. So it's not the double stem and leaf. Split stem is whenever you're going to be going 2, 2, 3, 3, 4, 4, and so on, okay? That's what it means when it asks you to split the stem, all right? Okay, moving on, and this is the part we're going to do together. So, number 4 asks you to take these 5 numbers, these are the Consumer Reports, 5 brands of Subaru cars, and asks you to find the mean and the median, and then find the variance and standard deviation. And we're going to do that by hand with the formula. I'm going to do that once through with you, even though we kind of did it with our heights. So let's take a look at these. I want you to now, and that's why I had you get your calculator, take these 5 numbers, calculate the mean and the median. All right, so I got a mean of 19.6 and a median of 19. So now I'm going to walk you through the formula right here because we're going to now find variance and then square root it to get the standard deviation. Okay, so in this formula, what part of it do you need to do first? What part of this formula needs to be done first? Well, this part. Find the deviations. So do you see down here? I'm going to take and find the deviations. That means I'm going to figure out how far the number is from the mean for each problem. Okay, for each car. So find each deviation. Do that now. When you are finished, I want you to sum up those deviations. What is the rule that all of those deviations will always do what? They will what? Add up to 0. So that's a rule. Those deviations, those distances away from the mean will always sum up to 0. Hence, the reason that we have to do what? Square those. So I now want you to take all of these numbers over here and square them. Okay, so you have now squared those deviations. So what is next in the formula to do with those deviations? Or those squared deviations? Sum them up. So we are going to sum all those up. And the sum of those squared deviations is 33.2. All right. Now, according to the formula, what's the next thing that we do? Divide by n minus 1, which if n is the number of items, and there were 5 cars, so n minus 1 is 4. So I'm going to take 33.2, and I'm going to divide it by 4, and I get 8.3. That is what you get before the last step of square rooting. So what you get before the last step of square rooting is called the variance. Okay, so that, come on over here, 8.3 is your variance. And so to take the standard deviation, I square root that variance, and I get 2.88. So that's my standard deviation. Okay, now look at what this next thing does, because we are interested in how things change when you put an outlier in them. And that's what's going to happen here. Suppose that a Toyota Prius of 44 miles per gallon is added to this list. So that means now you have 6 cars. The 16, the 18, the 19, 22, 23, and 44. How does 44 compare to the other data? It's a lot higher, so it's probably an outlier. So you have 6 pieces of data. Keep in mind, you also have to find a new mean. You cannot use 19.6 as the mean. And so now you're going to find this variance and standard deviation of that. Okay? And then you get to practice that 2 more times with number 5 and 6. You get to find the mean, the variance, and the standard deviation of these 2. They are small data sets so that you can practice doing them by hand. All right, any questions about that standard deviation process? Okay, then our second lesson, our second little mini lesson is going to be about histograms and cumulative frequency histograms.